Okay, guys, three sample problems. Example 4 from your textbook, followed by 5 and 6. Now, this is going to take your understanding and kind of push you a little harder, but I'm going to try to make it as easy as possible for you, so let's go. So, this says the graph represents what graph? That graph. Y equals f of x. Don't be confused by the language. Look at this is just saying this is f or f of x. Using y equals f of x, that means using this graph, how can you graph a combination of transformations? Guess what that means? It just says use the rules you've been learning. Now they give it to you slightly different, but I'm going to try to make this very clear to you. So they're basically saying if this is the parent function, graph this, make the necessary adjustments. Now, my graph's not perfect. I did my best. My final answers may not be perfect, but I'm going to do my best, and I expect the same from you. So your graphs don't have to be perfect, but you have to get the general idea and be pretty accurate. Try to. So notice I colored this pink, colored this yellow. The first thing we're going to do is we're going to ignore that negative. We're going to concentrate on this. It does say graph y equals negative f of x plus 2. Don't panic by the new look. It's just saying take f and make the adjustments. Well, what does this x plus 2 mean? It means move it left 2. So we're going to take this whole thing in pink. Now I'm going to use pencil first. Move everything left 2. So these very clear points here, I'm going to move them all left 2. So there's that left 2. That's left 2. This has to move left 2. This moves left 2. And this moves left 2. So I'm going to try to keep track of those dots and just draw the same thing. Everything has just been moved left 2. As you can see, my drawing's not perfect. But we're not done. We have a second thing that we haven't paid attention to, and that's the negative. Remember, if the negative's in front, that's our A. What happens if our A is negative? It reflects over the x-axis. So this point drops below this. I hope that yellow shows up. I better use my pencil first. This point drops below the x-axis. This point, which is up 3, is going to go down to negative 3. It just reflects over the x. That point right there is only 2 above, so we're going to go 2 below. That point right there is 5 above, so it's going to go 5 below. This point right here is about 7 above, so it's going to go 7 below. Again, my drawing's not going to be perfect, but all I'm doing is I'm taking the pink one and I'm flipping it over the x-axis. I went point by point. Some of you who are more creative, you could just say, hey, I'm going to flip it over the x, and you might be pretty artistic or skilled, and you can just nail it without those points. Okay, let's take that same idea, apply it to this one. So once again, oh, and by the way, so we're good. So here's the parent function. It's saying, okay, if this is f of x, see, we're going to make the adjustments to f of x. That's all this is saying. Well, this is plus 3, which is on the end, so that's my d. This is in the beginning, so that's my a. Now, you could do this in any order. You could do d first or a first, your call. I decided to do the a first. So, what happens when we apply that 1/2? Well, that's going to compress this thing by a half. Let me take a second here. Which means every y value is going to be cut in half. so it's going to be compressed. Now it's going to get messy, but this is up 2, so it's only going to go down, or up 1, half of it. This is up 3, so it's going to be about 1.5. This is up 2, so it's going to come back down to 1. I'm going to fill that in right now in pink so my brain doesn't wander. Okay? And now this is up 5, so we're going to go up 2.5, which would be right there. This is up 7. Half of that is 3.5, so that's going to be right there. So, as you can see, it was compressed. Everything was just knocked down, if you want to look at it like that, by a factor of a half. Every y value was multiplied by a half, got compressed. It's flatter. Now, the second step we have to pay attention to is 3. All that means is go up 3. So we got to take this pink one, every value move it up 3. So I'm going to start with this one. We said this is 3.5, so it's got to be 6.5. And basically, we're going to move everything up 3. So I'm going to make that point a little bigger. This is 2.5, so I got to go 5.5. This is up 1, so I go up to 4. This is up a little higher, like 1.5, so I got to go up 4.5. Takes a little tick up. This is up 1, so it's got to go up 3. And so essentially what we just did is we moved that pink one up 3 units, and that's where we would finish. That'd be our final product. So this answer, this whole graph, is that yellow one. Just like this one, this graph is our final product, which is that one. All right, there's example 4. Same stuff you've been doing, just looks a little bit more complicated. Next example, example 5 from page 18 in your textbook. This one's a little easier than the last one, I think, because you're used to this one. So our parent function's y equals x squared, which is just our parabola. F of x is labeled f of x. So this is our parent function, and they're saying now, all right, smarty pants, graph that, make the adjustments. Now what I'm going to do is I'm going to ignore this negative. I'm going to do that last. I know that's going to be a reflection over the x-axis. That's easy peasy. But I want to talk about this. Now I'm going to go ahead and make a bold statement and say the book is wrong in this one. Because if you actually look at this, inside the parentheses and the squared, and we actually follow PEMDAS, this would actually be 1/3 times 1/3, which is 1/9, and that'd be x squared. So the book says, if you read the instructions in it, and I could be wrong, I'm not afraid to be challenged, but the book says that it's been compressed by 1/3. They just take that 1/3 and they say, hey, it's been compressed by 1/3. That's not true. If you square it, like you should, notice this is inside the parentheses, so we got a little math to do. This has actually been compressed by a factor of 1/9. Now, I'm not going to be perfect about this. All I'm going to say is this gets really flat. So I'm going to go ahead with my colors here, and I'm going to make this adjustment and just make this pretty dang flat. Notice I'm not worried about being too perfectionistic there. And then the next thing I'm going to do is honor this move. In other words, I'm going to take h of x, which is just the adjustment I just made right there. It's a new one. That's all this is saying. It's different than g of x. This is when I applied this change to that graph, actually to that graph, it turned into h of x, just giving it a new name so I can track my progress. Then I go to the final thing, to find g of x, to actually finish the problem, I got to do this to my previous h of x. That's all this is saying. This is the language the book uses. So all that means is flip the previous one. So over the x-axis. So that means we'll go like this. And this is now this. which is g of x. I finished it. Okay? Next one. Again, parent function right there. This is just f of x equals x squared. That's my typical parabola. We're used to that, I hope. And you could easily just say, hey, right 4, up 5. You're right. But I want to explain to you how the book talks so that you can kind of understand this language in case it pops up on ACT, SAT, college entry exams, or, pre-calc next year. So this just says, all right, let's go one step at a time. We're going to call this h of x a new graph by making this adjustment only. That's why we're giving it a new name. This isn't quite the whole finished product, so we're going to give it a new name. This just says take the parent function, move it right 4. So, again, I'm going to make this pink. I'm going to move it right 4. So I know this point is going to get bumped to the right 4. There it is. Done with that. So now they're saying take h of x, which is my pink one, and add 5 to it. And then you will have found g of x, which is our whole goal. So we just have to bump that up 5 units. So here we go. I'm going to take that vertex, put it up 5, redraw it, and I'm done. Okay, just so you can read this problem to yourself, and I don't have to read it to you and waste up this time, I'm going to hit pause right now, read the problem, and I'll talk to you in a second. Okay, now you've had a chance to read it. The basic premise is, here's my y values, that's the distance from the station. Here's my x values, that's the time the train's been in motion. The train must be making like a circular path because at the beginning it's at the station, and at the end, after 30 minutes, it's back to the station. So with that in mind, you can take a look. It's asking you what equation or function represents the distance from the station. Now, that's pretty intimidating. So like, whoa, I have to build an equation? It's not that hard. Step 1, just recognize, hey, it looks like an absolute value problem, so my parent function is going to be y equals the absolute value of x, which looks like this. Now pay attention to that point. That point got moved to here. So I had to move right 15 and then up 15. So realize it's been messed up, so apply these rules to the absolute value and work backwards. Where was the original vertex? That's this point. Where's it been moved? Well, we said right 15, up 15. So we know we can make the adjustment here and here based on what we've been learning. Everything else we don't really know about. Now B, they're not going to mess with that. Like I said before, they're not going to mess with that too much. So we get y equals a, absolute value of x. Now, to move right 15, we got to go minus 15, the opposite. To go up 15, we just put plus 15. Now we're like, wait a minute, we're not quite done yet because we still need to find letter A. Now here comes the twist. How are we going to do that? Well, we know this point right here is 0, 0. We know this point is 15, 15. We know this point for sure is 30, 0. Any point on this graph, we can plug into this to find our final thing, and that's letter A. I'm going to pick the easiest. I'm going to pick this as x, this is y, plug it in. So my y is 0. I don't know what A is, I'm going to find it. My x is 0. And then plus 15. Guess what? You got an algebra problem to solve. Go figure. So this is 0 equals A. What's the absolute value of 15? Excuse me, the absolute value of negative 15 is 15 plus 15. I'm going to subtract 15, I get negative 15 equals A times 15. Divide by 15, I got to hurry, which equals negative 1. And if I put that right here, I'll have my answer.